Now this is chapter 6, topic 2. For topic 2, we're looking at a new operation that we've never done before. And this operation is called composition. Okay, this operation is called composition, and the way that you can recognize composition is it will be an open circle to describe the operation. Okay, and we'll see it in one of the examples. So let's first think about these two functions we're given, f of x, which is 2x minus 1, and g of x, which is 4x. Number 1 says find g of 3. Okay, well this would just explain to me to evaluate the g function when x is 3. So essentially I substitute 3 into the g function. So the g function becomes 4 times 3 instead of 4 times x, which is 12. So we would say that g of 3 is equal to 12. Okay, well how does this help us evaluate a composition? Well, if you look at number 2 is a composition. It says f compose g of 3. So here's how a composition works. What you do is you first find g of 3. And then whatever number you get for g of 3, you substitute that into the f function. Okay, you use g of 3 to evaluate the f function. Written another way, it looks like this. It says the g of 3 is the input for the f function. Okay, so whatever g of 3 is becomes the input for the f function. Well, we already determined what g of 3 is. It was 12. So 12 is going to become the input for the f function. So I'm going to use the f function, except I'm going to substitute 12 into the equation. So f of g of 3 would really be f of 12, which would be 2 times 12 minus 5. 24 minus 5, which is 19. So we would say that f compose g of 3 is equal to 19. And that's how we perform a composition. Now number 3, you'll notice that it says f compose g of x. And there's no numbers to substitute into the function. Okay, it just says f of g of x. Okay, so here's how you do it if you don't have a number to plug in. If you don't have a number to plug in, we're just going to use the entire function as the input for the f function. Okay, so essentially what we're going to be doing is we're not going to be plugging a number into the f function. We're going to be plugging another function into the f function. The g function will be plugged into the f function. So another way to read this would be the g of x function going inside of the f function. So how do we do this? How exactly do we do this? Well, there's a really easy way to do this, okay? First, we're going to write the f function, the first function. We're going to write the first function, except whenever we see an x, we're going to put a parentheses. So here's the first function, 2x minus 5. So I'm going to put 2 parentheses minus 5. Inside of the parentheses, I'm going to put the g function. Okay, so the g function is 4x. So I'm going to put 4x inside of the g function, or inside of the parentheses. Okay, so this would represent the g function being inside of the f function. And now I can simplify. That's 2 times 4x is 8x minus 5. And this is a new function. This is the f compose g of x function. This is the composition function. And that's all there is to it. That would be our composition. Now, order is important. There's no such thing as the commutative property for composition. Okay, order is important. You can't change the order and preserve equality. So if we look at number 4 is g compose f of x, different from f compose g of x. This represents the f function being placed into the g function. Okay, the f function is the input for the g function. Okay, so how do we do this? Well, this time I'm going to write the g function with parentheses instead of x's. So look at the g function, 4x, so it's 4 parentheses. And inside the parentheses, I'm going to put the f function, the inside function, which is 2x minus 5. I'll use the distributor property to simplify this. So 4 times 2x is 8x. 4 times negative 5 is negative 20. So this represents the g compose f of x function, 8x minus 20. Let's try some more. So f compose g of negative 1. So this tells me to figure out what g of negative 1 is and then put that into the f function. Okay, g of negative 1 is going inside of the f function. Alright, so first I need to know what g of negative 1 is. It's negative 2 times negative 1 plus 1, which is negative 2 times negative 1, which is 2 plus 1, which is 3. So g of negative 1 is 3. So I'm going to be using 3 as the input for the f function. So I'm going to be looking for f of 3. So 5x, so 5 times 3, which is 15. So we can say that f compose g of negative 1 equals 15. Alright, next, number 6, h compose f of x. So this would be the f function going into the h function. The h function, and the input of that is the f function. Now this is just another way to write it. You don't have to write it this way. It's just another way to show us that f is going inside of h. So I'm going to write the h function with parentheses where the x's are. So here's the h function. So parentheses squared plus 6 parentheses plus 8. And inside the parentheses I'm putting the f function. So the f function is 5x. So 5x, 5x. Alright, I just need to simplify this. So 5 to the second power is 25. X to the second power is x squared. 6 times 5 is 30. And then plus 8. So this represents h compose f of x. And this would be our new function, h compose f of x. And then two more, g compose h of x and h compose g of x. So this would be the h function going into the g function. So I'm going to write the g function with parentheses. So negative 2x plus 1. And inside the parentheses, I will put the h function. So x squared plus 6x plus 8. I'll use the distributor properties, simplify this. Negative 2 times x squared is negative 2x squared. Negative 2 times 6x is negative 12x. Negative 2 times 8 is negative 16. And then I still have the plus 1. If I combine the like terms, negative 2x squared, negative 12x, and then negative 16 and positive 1 combine to make negative 15. So this would be my composition function. G compose h of x is equal to negative 2x squared minus 12x minus 15. And then h compose g of x, this would be the g function into the h function. So the h function gets written first. So x squared plus 6x plus 8. And inside those parentheses, the g function, so negative 2x plus 1 and negative 2x plus 1. Okay, now this one's a little bit harder because we have to simplify all these pieces. Okay, and if you look at this piece, negative 2x plus 1 squared, this is actually kind of hard to simplify. So let's think about how we would simplify this. First, we would write it as negative 2x plus 1 times negative 2x plus 1. Because the squared means multiply it twice. Then we would use the distributive property. Negative 2x times negative 2x is 4x squared. Negative 2x times 1 is negative 2x. 1 times negative 2x is negative 2x, and 1 times 1 is 1. Combine the like terms, 4x squared minus 4x plus 1. Okay, so that first part is that. So this part becomes 4x squared minus 4x plus 1. Alright, the second part we just distribute. So negative 12x plus 6. And then we still have the plus 8. At this point we can combine like terms. So 4x squared, negative 4x and negative 12x make negative 16x, and 1, 6, and 8 make 15. Alright, so this is H composed G of x. And that is how you perform a composition of functions.